good to see him back here.
Thank you. Thank you. Don't mind if I'm going to run a little late. I've already done. Okay. As Nelson said, it's really nice to be among old friends after such a long time. Those who've known me for a long time, or even short time, know that I like to play with words. And so this talk is both about workflows and designing workflows for engineering documentation, as well as engineering those documentation workflows. It's a double entendre. My standard disclaimer for all my talks is there is nothing new here. And Carl is, for that reason, placed me right before the break, and those who get bored, coffee is served. There's also quite a bit of material to cover, and I'll be skimming over the majority of it. Or as my late grad school roommate Selvaraj used to say, just skip the gruesome details. And I'll probably end up talking like Alvin and the Chipmunks at double speed. My interest is in engineering documentation, in particular specification-driven documentation. So I'd like to quickly run through some of my talks, the topics of my talks, not to bore you with nostalgia, but just so that you can see, like I have begun to realize, that they were just steps along a long path. To begin, in Boston, I spoke about this workflow which related to project estimation. YAML was used for specification, LaTeX for output, and I had standardized on a model view controller framework with tech and the associated utilities for the view. Then came Tokyo, Tansu. Tansu was, I used John's very excellent asymptote package to create interactive 3D wire models for cabinet layouts like you'd find in kitchens. And YAML was used to store both the vendor catalog of cabinets and the kitchen design. And of course, the day before the conference began, I made a fatal mistake. And not for the first time. It happened on this conference as well. I initiated an OS upgrade, which completely bricked my asymptote demo. So there I was, adrift in Tokyo, scared and alone, looking for a fixer. And I found one. And he wasn't Yakuza. The man in the corner, Norbert, not only was one of the hosts of Tokyo, but he was the package manager for asymptote, for Debian. So I chased him down in the hallway. That was my introduction. Norbert, you may not remember. And he pulled from upstream, saved the day. Next was Sutra in Portland. It dealt with documenting signals. And I mean signals in the systems theory sense, not just in the electronic one. You know about the playing with words. Five Eyes was a nod to Five Eyes, the alliance in happier times. Most documentation deals with the first two, identity and interface. Since that time, I have focused on adding the bottom three into documentation workflows. Sutra came about because I was trying to diagnose this boiler system and really struggling to map out the network, the electronic controls, the piping, and whatnot. And I took inspiration from something known as the Noguchi filing system, which I implemented in context, and I've experimented with many non-linear scroll documents, as Jean-Luc Demont calls them. So, in summary, I'm interested in how do we capture information, how do we organize it, and how do we communicate it? Simple task. And for those who may not know the 1960s anthem, what is it good for? The rejoinder was absolutely nothing. So yesterday, Eric spoke about the generosity of the tech community throughout the world, and Corey and I spoke about it just this morning. So let me tell you a little bit about my own story. I arrived at TUG 2010 not knowing a single person, other than Carl's warm emails accepting my naive talk topic. I have had no interactions with the tech community until that point. To say that I was intimidated would be a severe understatement. Like at the 10th anniversary that Barbara spoke about, all the Stanford tech luminaries were there. Professor Knuth gave his very famous talk of e-tech. And I had barely a few scores of successful LaTeX compiles under my belt. So during the talk I gave that year, which was about mathematical literacy, I mentioned my love of nomography and alongside other calculating devices, analog and digital. I returned back to Toronto and was immediately overwhelmed with the cut and thrust of daily responsibilities. A short while later, a package arrived in the mail. And in that package, amongst its contents, was this. It's a flight slide rule. Boris, I don't know whether you remember, you sent this unbidden to me. That is the generosity of the tech community. And I think the kindness and generosity is what will sustain us in the future. Okay, so let's begin with discussing document creation. Documentation creation is focused on implementation of engineering system. It's rarely, if ever, worries about usage. And what it means is the audience are the various trades whom are usually siloed, and they're not talking to each other, never mind the people who are going to end up maintaining the system. The end result is a mishmash when you really want a proper man page that describes the behavior of the system as it was commissioned. So here are some of the challenges faced in documentation creation. Access matters. When you are confronted with a system like that, and maybe you can't even access the back of it without destroying it, you better be very, very careful. Scale matters. We'll get back to this project later, but if the system's large, complexity is added. I don't have the photo here, but I'll show it to you later. Safety also matters. You'd be surprised at how this enters into documentation creation. So the consequences are you get inadequate end-user documentation, and like its namesake, incendiary explosive device, you have to handle it with care. And we need risk mitigation for when we create documentation. So what we need is the equivalent of the dry run flag in rsync, because as I'm sure all of you know, if you swap source and destination on an rsync -- delete, you are in big trouble. So the best way I know of gaining that knowledge is an audit, an engineering audit. Okay, the next couple of slides are going to look like a McKinsey PowerPoint from 2001. I apologize. Touting the virtues of clicks and eyeballs, but just bear with me. They do have real-world implications. Base requirements, capture and verification. and judge efficacy as efficiency and utility. Now, before we get to know how an audit fits into documentation toolchain, I want to touch briefly on a core concept to its creation. Some of you may know of Adam Savage. He's a special effects creator and a host of a very popular YouTube channel. That's not how I know him. He came up with this idea and concept, which has gotten really good traction, called first-order retrievability. This explains it a little bit more. Essentially, you shouldn't have to move a tool out of the way to be able to access it. I look at it a little bit more broadly. Here's a counterexample. This is my late father-in-law's toolbox. Yes, you may have to move a thing or two before you access it, but it worked for him. Amongst the trades I know, this is more common, and this happens to be one of my maintenance pouches. But how do you achieve first-order retrievability? Before you get to retrievability, especially with information capture, you need transcription. So, only transcribability can lead to retrievability, and here I'm using first-order retrievability has a prime mover, that being first-order transcribability. And I'm using it in the engineering connotation, the initial force whereby natural energy might be converted to work. Corey can tell us if I'm still within bounds of using prime mover in the classics Aristotelian sense. Without transcribability, retrievability is wishful thinking. It does not happen automatically. So this is what I call a transcription surface. Start with the project. These are electrical panels mounted on a roof high above the suspended ceiling tiles of a restaurant inside a luxury hotel. The concrete floor is, if I remember correctly, 20 plus feet above the ground, which was filled with all expensive furniture and whatnot. Here's another one. So I took these photos while standing atop a 10-foot step ladder, and by top, I mean the very top of an A-frame where it's imprinted, do not step. One hand hanging on some of the cables that hang on to the grid. Talked about safety matters for documentation creation. Case in point. So this is remarkably well labeled by the electrician. Most electricians will not do this. Unfortunately, it's completely devoid of the information that's needed. Here are some of the problems. Yes, it has in situ labels, but there are 3 different electrical panels in different parts of the restaurant, which means you have to go up and down to try to make sense of it. There's no physical topology or anything like that. It gets even worse on the controls side. Controls have hard addressing, soft addressing, load mapping. None of that is there. So what's to be done? What then must we do? I came and did an audit. And I did the addressing. I mapped all the light loads, the panels, the hard addressing, the soft addressing. Veet, you may recognize the pen. I picked this pen up in Kutnahora during one of the context meeting excursions. It's standard issue, I'm told, for engineering, or at a certain point, for engineering students in the Czech Republic. It's a Koh-i-Noor 4-color pen. So after I'd done all the initial lighting scenes, a lighting consultant was called in to tweak the scenes. When he saw my notebooks, he could not hide the disgust. Don't you use Excel? It would be so much easier. No doubt he was left wondering what form of computer illiterate had been hired to program this system. I'm not here to convince you that an analog approach is preferred, but I hope that through this talk, you, like me, might at least question the path dependence of digital only. This slide also has an interesting artifact because it demonstrates prior art. In engineering, prior art is important. You need to know version history, and you certainly can't do that with Excel. It may look rudimentary, but it's very helpful, And it ended up being so. The lighting consultant kept asking me, well, for that light load, which intensity levels have we tried? And I could just show him. That's the progression. Useful. So what is a transcription surface? You've seen the analog part. It's an analog input form combined with purpose-filled markup. Essentially what we're doing is creating a microgrammar that allows you to go seamlessly between system verification in the field and a suitable data representation feeding downstream processing, i.e. documentation workflows. It should serve the audit function upstream where time is a very tight constraint and human resources are at a premium, while still having sufficient structure, sufficient syntactic sugar to be processed by machine. I introduced this topic at a context meeting in Dreifelden, and my submitted title was the second one, and Raban kindly pointed out that if I was going to have illusions or pretend to have illusions of German, I should at least get the correctly gendered definite article. So he corrected that for me. All right. We're all familiar, I think, with tabular and hierarchical, but input form type topologies can come in different, with other topologies. For instance, large facility control systems, this is a relatively small one, will use daisy chaining with T-taps to connect up certain devices in the field. It would be far too expensive to home run everything the way we're used to with Ethernet. I think most of us have forgotten about token ring, which was a T-tap topology. These chains span out radially, each on a separate link or bus, hence the title, Wheels of the Bus. The purpose of the transcription surface is to recover the information gap between design and implementation. This is an active process and not just simply a passive one of capture. By necessity, this requires inquiry, observation, reasoning, validation. The questions to be asked are, what input form serves the purpose and constraints best, and what can we do with it afterwards? So let's take a really big example. I showed you that panel, the panel room. That was one of 11 panel rooms split across 2 buildings and 5 floors. Not 5 contiguous floors, but 5 staggered floors. A really big deal. And I had introduced the idea of live system risk. Well, I hope you can see that this is very real when you're the person responsible. And this is the documentation we get to work with. You have lots of blanks. You have this metronome of phase, A, B, C, D, which is ABC, ABC, which is useless. For some reason, you're given line numbers, which no one will ever refer, alongside load numbers, which you might refer. You've got duplicate nodes or leaves of the tree, and the real information you need are in the dots, which means that the report is completely useless. So what you've got is obscured information, duplicated information, missing information, overloaded fields, no contextual notes. You seem to have the sniffles. Let's do an audit. In our house, we have a running joke whenever anyone's under the weather. You seem to be showing signs of being under the weather. Let's start with a lumbar puncture. We were fans of House MD, and in every episode, for whatever reason, Dr. House would say, let's start with a lumbar puncture. Tight constraints, we talked about time and human resources. Bar and restaurants open till 1. Residence lobbies are open 24/7. This is multi-building. There's a luxury residence building attached to this hotel. And these residents are very unforgiving to disruption, as you can imagine. Hotel light duties. We have to do the work between 2,300 hours and 5 o'clock the next morning. This may be obvious to most, but just in case, observed light requires darkness. You have to flick lights on and off to identify light loads. People notice, and you have to do it in order to find out which light connects to which circuit. There's also this issue of comms blackout areas. We as guests only see front of house. In Here it's small, but in large hotels, there's a whole back of house. Subterranean caverns of workshops and housekeeping and whatnot. They are not provided with cell phone boosters and all of that stuff. There are areas where there is zero signal. So the audit process can be broken out into different elements. I break it down into these 5. The first 2, capture and engagement, form the core. I put delegation and verification together because with these large facilities, you are inevitably going to be relying on teams to span out and help you verify things. And finally, we have abstraction. We are still trying, while in the field, to resolve inconsistencies, attribute function, and motivation. Arash spoke of this yesterday, but I promise you, I've had this slide for months. In my experience, analog input has many benefits, not the least of which is learning about the subject matter through writing. And those who are interested should most definitely do a deep dive into Zinzer's books, and this one in particular. Delegation verification. Don't always assume connected. So as I mentioned, hotels don't spend money on cell phone repeaters in the back of house. So what we ended up doing is actually from that very panel room, we ended up doing a fire brigade. And equipment rooms are noisy. So I was inside the equipment room, someone is at the door, down the hallway, there was another relay, up the stairs, there was another relay, and then the team had phone signal, and they would span out to do verification in the field. And the signal would come all the way back. Again, analog can prove useful. The other thing is team members don't have in-depth system knowledge. They have other knowledge, which is really valuable, but not necessarily system knowledge. So the transcription surface format has to allow for that because you're going to delegate this. I long loved this quote by Dijkstra. Some people find it helpful to start with a theoretical and then apply it to the concrete. I learn better by confronting the empirical and abstracting patterns from it. Okay, choice of markup. Rishikesh and others have talked about XML. It's well known. Long-form documents have such well-defined input representations. However, they can burden the document markup so much that they prevent direct editing. And keep in mind the time constraints and the resource constraints we have to deal with. Ah, yes. We're all familiar with the human readable part. We rely on markup so that machines can process it, but that choice is an artificial one. It should not be biased solely on the processing, which is for the machine, but in our case, we have to bias it towards a human for the capture of the information. And so human readable is a throwaway phrase, but I would say it's a very low bar. Supposedly, this is human readable. I can understand evaluates a determinant. The rest is Klingon to me. It's APL. So purpose-built markup does put a burden on having to parse the markup by yourself. But there are well-defined tools that can give you an assist. Here's an example of just a small bit of microgrammar. So the way this was done was I designed the microgrammar, we did it analog, pencil and paper, and then we did a text file. And you can see there's a little bit of notation there about the load. And there's other elements of it. And then we would take the printed version, enscript it, send it out in the field for verification. And this is the legend. And before we begin, Barbara, Carl, I'm so sorry, there's a spelling mistake. Verified is misspelled. I can assure you this was an early version when the screenshot was taken. It did not hit the final report. But I want everyone to notice this part. We actually took note of this. Handwritten notation on printed light load table or on painter's tape. Sometimes a technician will put some note on the breaker with painter's tape, just the way we have there. they have tried their best to add to the institutional knowledge of the system when the institution itself has no clear structure to capture that information. The audit allows you to do that. So this is again just the same light loads with the notation, something that the maintenance staff can understand and sustain the system in the field. Okay, we're back to terraforming now, or we're not back, we're now terraforming. Another site, another bunch of electrical panels. You've seen this. This is a luxury retailer. Holt Renfrew has a store down there if you have unexpectedly come in to the lottery. There's a slight issue with the system. There are no keypads. Or I should say more properly, there are only keypads in private shopping change rooms. The whole store, not a single keypad. Sounds like a simple problem. There are issues. Lights are burning 24/7. Whether they be interior lights, exterior lights, signage, display windows. Not good when you're advertising that you're trying to hit sustainability targets. One is forced to use breaker control or a button-operated menu to change the lights, switch lights on and off. So I was asked to program into the system, and there are 3 different systems across this store, time clock events. And I thought about it, and I went back to them, and I said, you know, that's really dangerous, because if the lights are off at night and emergency services are called in, there's no way to switch the lights back on. Risk. More constraints. This time we're only given 2 hours in the morning, and that time is shared with staff who do store cleaning, display prep, staff meetings. Standard audit. DNF, do not find, decommission, possibly. After the audit, we proposed to the client a control system acting as a single sheet of glass across all 3 processors, and I'll explain that in a little bit more detail. The desired features are local operation, offsite operation, time clock events. The distilled functionality, basically all you want to do is you want to set the light level somewhere in the field, or get the light level and display its state. Now, I can already see those people who haven't gotten bored. Your VMs are spinning up behind your eyes. Docker, Podman, Nginx, Apache, Postgres, Mariah, Flask, Laravel, you know, the full gamut. LibSocket, or maybe, you know, Carl and I probably still have our copies of W. Richard Stevens' network programming. We're thinking, oh, we'll just do it in C. Let's just pause for a second. De-risking. 2025 Free BSD Dev Summit, Michael Windsor. Alpha Omega is sponsored by the Open Source Security Foundation. He focuses a lot on de-risking open source software, open source dependencies. The idea is to minimize dependencies, and so on. I am partial to an earlier expression of the same idea. It's known as Chapman's Law, and car enthusiasts may remember this. Colin Chapman said when he was designing his Lotus sports cars, simplicate, then add lightness. I can't think of a better way to engineer software. So then what is terraforming? We started with a transcription surface and a markup, analog and combined. Can we use it to create an end user application, the same transcription surface? Well, we know it served the maintenance staff, but can it now serve the operations staff? And if we expand the use of the transcription surface to serve 2 different constituencies, and we simply aggregate them as a set of sets, well, we know that ends up in Russell's paradox, right? Maintenance staff need detail and depth. Operational staff need simplicity and clarity. So what is required when we're trying to design a control system out of that same transcription surface is additional semantic layering that has nothing to do with the electrical topology or even the controls topology. And I called it grouping. But let's just revisit the hierarchy. Into the processor, you have a panel and circuit. From the processor, you have this idea of floor, room, load, and zone. The problem is some loads may not be attached to the same processor. So operations staff doesn't care. They don't want to log into 3 different systems. The site reality at the project that we're talking about was highly non-conformant. You had a split level grate, so even the concept of floor doesn't exist. Interior, exterior, mall interior, back of house. So this is the nomenclature I came up with. Light loads belong to areas, areas belong to department, departments belong to districts, districts belong to building levels. Notice nothing about the processor or the bus. So here, I just took a screenshot. This is it in action. So for instance, women's wear, colored similarly, and it extends below, can consist of non-contiguous areas on the retail floor. Curtain grazing down at the bottom runs along the whole perimeter of the store, and because some of the floors are mezzanine, they span both floors. Software approaches considered. Hand-tooled, sorry Norbert, vibe-coded, not a chance. What we settled with, transcription surface. Remember, I standardized on MVC whenever it was, 2012. Some of us are, I'm not going to say our age, some of us might have been members of LCIS, the Library of Computer and Information Sciences. It was like a book of the month club for nerds. You'd get 3 books and you were allowed to evaluate and return the ones you didn't want. I remember when this book came in, Unix Relational Database Management by Manish, Schaffer, and Jorgensen. It was like mind-blowing to me. There is an open source project called FSDB, which purports to take some of the ideas of /RDB. I couldn't make it work, and I ended up using CSVKit. Okay, configuration, model part 2. It may seem ironic since I've spent so much of my early time talking about YAML, but I adopted RCL. If you take nothing away from this talk, more than this, do a deep dive into RCL. Ruud van Asseldonk wrote this very excellent and biting article about the YAML document from hell. So what is one to do? He, of course, writes his own config language, which is a superset of JSON, very elegant with control structures. I used RCL for color palettes to be complementary, other CSS, JavaScript snippets. Now, another anecdote. There's a wonderful craftsman that I worked with who was also a great teacher, Frank Ropos. And he was the kind of person you would imagine having found in Zen and the Art of Motorcycle Maintenance. His fastener cases were very counterintuitive. He would, you go to Home Depot or whatever there is, you see them all row sequentially up or down, right? Half, 5/8, 3/4, 1 inch, et cetera, et cetera. His fastener boxes would have sufficient differentiation across adjacent cubbies so that it could never mistake one for the other. He would never put a half next to a 5/8 because it's too easy to mistake. Similarly with color palettes, it's important to have that differentiation. Semantic layering, we've talked about this. The grid layout and processor bus details were all stored in RCL. Quickly go through the view, the rest of it, Lighty, Lua, and minimum CGI wrapper, static HTML. Going back to de-risking software, in recent years I've taken great inspiration from static site generators. There is no need to build this huge complicated edifice atop a CMS for it to come down crashing at an inopportune time. The front end work, I got a lot of heavy lifting by my cousin nephew, Bart Chauhan in New Delhi. He's a great open source developer. If anyone is looking for someone talented, reach out to him. Controller was a self-contained Lua app with local modules tree, again, de-risking. Okay, let's revisit models part 3. We have to talk to the processor. As much as I would have loved to pull Stephen's book off my shelf, I just needed something reliable. Expect scripts do that. They work all the time without any fuss. Here's a sample of the telnet session. Looks all very straightforward. There are some wrinkles to be had with level, fade, delay, and zones. So let me show you that. All right. Zones are decimal at the processor. API, they're hex. This is fairly trivial because it's a one-to-one mapping. It gets a little bit more interesting with intensity levels at the processor, like when we do the audit, 0 to 100%, human readable, API still 0 to 7H. Similarly with fade and levels. So what's one to do? My gratuitous Unix command. This is a DC that converts reported intensity hex into percentage. Now, I put the comment down below because I find it freaking cool that DC is the oldest surviving Unix language program, and I am using it to solve a problem in 2026. And I can only imagine what Lorraine Cherry and William Morris must think or have thought if they knew it was going to be embedded in if they included an embedded system. This is OpenWRT because we're given access via a general building automation network with lots of promiscuous devices on it. So I put my firewall. This is FreeBSD on a Celeron N100 running Ujala, the application. Okay, quick demos. I hope this worked. This was a test of the expect scripts. And, oh, this is great. You got it in loop mode. Excellent, thank you. And then this is with the floor plan view, what the operations manager would see. And the effect is a little bit washed out, but Parth had done some undulating. The status of the zone or the department is identified with that. Okay, conclusions. Using transcription surfaces gives consistent and very effective results in creating engineering documentation for as-built reality rather than as-designed plans. But there is so much more, much, much more. By decoupling input markup and document markup, we can also create parameterized applications or terraforming, if you'll indulge me. And if there's errors in the original transcription, it's a simple matter to modify those and go through the full life cycle, generate documentation, as well as regenerate the application. There was no manual intervention to what you saw in the demo. Finally, the added semantic layer can be combined to create end-user documentation, even after the application's written. I'm going to skip this part, but you may see that this is not a typical Beamer package. It's because when you're wearing transcription surface glasses, you see everything as a nail. So I wrote my own markup, and this uses LPEG in context to generate these things. I talked about this a little bit in another talk, context meeting talk, Zettelkasten for non-digital nomads. This is how I wrote this presentation even before I had written the software. All right, one final story, the epilogue. If you'll, I know, but just give me 30 seconds. I ask your indulgence, if that's okay. Those who want to go for coffee, it's outside. I began this talk by saying that there's nothing new here, and let me drive that point home emphatically. On this continent, it is mandatory for all children to visit a Disney property. And if you fail to do that as a parent, you will be marked for gross negligence. And not only that, the relationship between your children and yourself will be ruptured, and any setback they face for the remainder of their life, they will point to that trauma. I resisted for a long, long time, but then finally accepted with one condition. If we had to make the trip to Orlando, we would also have to allot one day for Cape Canaveral. During the visit, we signed on for a bus tour that took us through the history of NASA's various eras near Launchpad 39B, I tried to explain to my kids about the extreme heat those ceramic tiles had to withstand. No interest. My son was doing parkour over some of the displays. My daughter is dreaming of the pool back at the resort. Kind man came up to us and talked to us. He talked about how cooling was done in the shuttle engine. He was a propulsion engineer on the shuttle program. Final stop was Apollo, much diminished because for people of our generation, Apollo looms large in our imagination. I was out of patience with my kids. The kids were out of patience with me. We went our own separate ways. I was reading the description about the Lunar Command Module. My daughter runs up to me, Papa, there's an astronaut. Now I had in mind some actor, great for kids. He can engage with them. So dressed in full regalia, whatever. Papa, you have to come now. He's about to leave. I said, okay, I'm still trying to process this, right? Like, why do I need to see Buzz Lightyear? I know the kind of story, right? Then she said the most dangerous words for us in this audience. He was signing books. Well, I followed her. She's running, with her pixie legs as fast as she can. I'm trying to move quickly without creating a security incident. I didn't want to be tackled on my way back to see what she's talking about. So I went back to see what was happening, and indeed, table was there, boxes were packed up, the gentleman was leaving. Does anyone recognize this, and in particular, whose handwriting this is in red? Anyone? I know I'm out of time, and I've indulged you far too long. This is the handwriting of the late Commander James Lovell of Apollo 13. This is part of the 75-page checklist that he annotated along with, and I've forgotten the astronaut's name, who was left behind because he fell sick. And they collaborated to bring the crew safely home. To me, there's no better example of a transcription surface. Yeah, the stakes were pretty high then. So all I can say, I forgot. Last prop. This is the book he signed for me that day. So you're welcome to look at it. We would all do well to look up at the sky once in a while and imagine the possibilities. Thank you for your indulgence. Sorry for taking this.
Thanks much, Pavneet. We'll break. There won't be time for questions, but you can grab Pavneet in breaks. And we'll
Boris, I know. Here's the book.